Hi class, we are doing 18.4 now. 18.4 is trig ratios, and that's pretty much what we talked about last time. What we just discovered with 18.3, we discovered what we're going to learn in 18.4. So it was mostly a discovery lesson that will help you understand what we're learning right now. What we're learning are the trig functions. So I mentioned them in the last video. So hopefully you'll remember that little bit of background information that you just recently obtained. Trig function is a function whose rule is defined by a trig ratio. So it has to be defined by a trig ratio. So, and it is a function. They have actual graphs with these trig functions. So, for example, it would be sine theta is opposite over hypotenuse. So, or y equals sine theta is the actual function itself. It has a graph, it's a sine wave. It goes like this forever and ever and ever in both directions. And it is a function with its own graph and its own properties. And same thing with cosine. We have cosine and then tangent also. I can show you those real quick. If I have y equals, just because they're interesting, you're going to figure them out. Eventually, you get to study them, you graph them, all sorts of things when you get into 3 honors. That's a cosine graph. It looks like the sine graph, but oh, you know what? I did the sine graph terribly. That's so terrible. Sorry, I haven't taught these sine graphs. I haven't looked at a sine graph for probably 5 years now. So anyway, it goes up at the origin, and the cosine crests at the origin. But they're similar. They're just shifted. Call it a phase shift, moving it right or left. The tangent's a little different, but it's also a very useful graph, although it has a bunch of asymptotes, but it looks like that. It's pretty cool. Hopefully one day I'll get to teach those again, but those are the trig functions, and a trig ratio is actually what the sine theta is equal to. It compares the lengths of 2 sides of a triangle. And in 18.3, we learned that there were 3 sides. One's the hypotenuse, one's opposite, one's adjacent. And so when you take the ratio of the 2 sides, it compares the lengths of 2 sides. And what happens is you get a very specific decimal answer. So it's equal to some opposite side length divided by the hypotenuse length. And it is the same thing every single time. As long as you get the same angle, you have a bunch of similar triangles with the same angle, they're always going to have the same trig ratio. So the Greek letter theta, okay, is often used to represent the measure of an acute angle. Now it's acute because in the right triangle, the right angle is 90 degrees. The other 2 angles are considered the acute angles, and they add to 90, therefore must be smaller than 90. And that's why they call them an acute angle. And those are the only ones we reference. We don't reference the 90 at this point. We're just referencing the 2 sides, or the 2 angles that are acute angles. All right? Now, when you have this trigonometric function here, you have, I'm going to try to move this over a little bit. Move it over. Okay, so you have this triangle. You have the theta here. That's going to be your angle that we're referencing. So that's this angle right there. Oh, I hate it when it does that. Just obnoxious. Okay, so with that angle, the sine theta is opposite over hypotenuse. All right. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So when we're looking at the angle, does that move? Woohoo, I guessed right. We're looking at that angle. For the triangle, we had you write those down. I remember this was the hypotenuse always. Okay. If I look directly opposite the angle, what I see here is A. So that's going to be opposite. And this side, let's see, that runs right, that one goes way down, is going to be adjacent. Okay, it's your adjacent side. It runs right into the theta, the angle. So the mnemonic SOHCAHTOA is useful. It's an acronym useful when you're memorizing the ratios. So SO means sine theta is opposite over hypotenuse, and that's where you get the S for sine, opposite over hypotenuse. So O goes over H, and it's first in the acronym. Cosine theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So you can know those every single time. It's just easy to remember. So when you see ka is adjacent over hypotenuse, then you can think of cosine theta is adjacent over hypotenuse. When you see TOA, remember TOA, tan theta is opposite over adjacent. So we have all those to memorize or to remember. And I see SOHCAHTOA all the time referencing cute little Indian gear and stuff. But it's easy as an acronym to remember that sine theta is equal to the opposite over adjacent, cosine theta is equal to the adjacent over hypotenuse, and the tan theta is equal to opposite over adjacent. Pretty easy to remember. Now, because in this case, you're going to note that there are 3 variables every time. Okay, and it's a little more complicated. That's why it's at the end of the year. It's complicated because one's an angle. You have theta, that's an angle. That's one of your variables, so you have to have a measure of the angle. And then the opposite side, and it's just a length, and the adjacent side. And it's just a length also. So we have an angle, theta is opposite divided by adjacent, and it happens every single time. And you can always remember that, and that relates the opposite to the hypotenuse. Now we have choices. We have sine, we have cosine, and we have tangent, because when we're figuring out the side lengths or the angles in triangles, in the study of trigonometry, the measure of triangles, then we might have 2 different sides, and we need to relate those 2 sides to an angle, and it's not always the opposite in the hypotenuse. So we can't just only have sine. And it's not always the adjacent and the hypotenuse that we are looking for or know. So we can't always just use cosine. Neither do we always know just the opposite and looking for the adjacent, or vice versa. So we need all 3, because all 3 relate 3 different sides, and depending on what we can and cannot measure, or what measurements we actually have, will be which of the trigonometric functions we actually use. Okay? So that's why we have 3 different ones, and you just have to remember which ones relate which sides, and therefore you have to, after looking at the triangle and analyzing it, then that's when you can decide which of the 3 trig functions you need. Now at the beginning here, they're just going to ask you to find sine C, or sine A, or sine Z, or cosine, and so forth, and that's because I'm just trying to get you used to looking at the 2 ratios. So for sine C, now sine, if you can remember, so, right, opposite over hypotenuse, and you always write sine, then its angle that we're referencing for the 2 sides is opposite, which is, this is C. A lot of times I will highlight it, something so I know, well, that's C right there. So find C, and then label hypotenuse and opposite. That's what I would do. Okay, for sine, now I would not label A at this point, because you don't need A, you only need O and H, and you remembered so is O and H, opposite over hypotenuse. So then you just have to take your labeled O, which is 5, divide it by your labeled H, which is 13, and you're done. All right, so sine C is 5 over 13. Now the sine of A, so again, let's highlight A here. That's the angle we're referencing. And remember, sine is opposite over hypotenuse, so we'll do sine A. We always write sine A equals, and it's going to be opposite, which is 48. Oh, I didn't write O. And hypotenuse is the 50 part. So 48 over 50. Now, we can't ever leave that as a ratio like that. It has to be simplified to its simplest form. Usually we like to leave it in fractions, even though when we're finding measurements, we always go down to the decimal. But we can divide out of 2, and we get 24 and 25. So sine A is 24 over 25. All right. So again, we look at the referenced angle, sine Z. So we're looking at Z. Remember to ourselves, so okay, sine is opposite over adjacent. We write the sine Z, sine of the angle Z, meaning opposite over hypotenuse for the angle Z, is going to be, let's look directly, O, opposite is 16, hypotenuse is 34. All right, so we have 16 over 34. And that simplifies. You can divide out of 2, and you get 8 and 17. All righty. Okay, So that's how you would figure out what those are. Now we're going to find some cosines and tangents. I can move this down. So cosine C, again, we're looking at C. Then we figure out cosine is ca adjacent over hypotenuse. We write cosine C is equal to, and then we find opposite and, cosine we need adjacent. So that's, hypotenuse is 13. It's always across from the 90. And adjacent is one of the two legs, always, and it's the one of the two that run into the hypotenuse. So that's, or to the angle. So that's A. So it's going to be, that's nice to erase, 12 over 13. Okay. All right. Cosine A. So again, we're looking at A here, this angle. And remember that cosine ca is adjacent over hypotenuse. So adjacent is, let's label these. Adjacent and the hypotenuse always across from the 90. All right, adjacent runs right into, it's the leg that runs right into it. It's good probably to find the hypotenuse first, if I can remind myself. At this stage of the game, you're not as familiar with it. And the hypotenuse also runs into the angle. So you have to make sure it's one of the two legs that you label the adjacent. So label hypotenuse first. It's probably better to label hypotenuse first. All right, so cosine A is equal to adjacent, which was 14 over hypotenuse, which is 50. And then once again, you can divide out a 2. So cosine A is 7 over 25. All right, cosine Z. All right, so our angle Z, adjacent, leg, and hypotenuse, 34. So hypotenuse is 34, and adjacent is the leg that runs right into it, and it's 30. So 30 over 34 simplifies to 15 over 17. All right. Not too bad. All right, tangent is TOA. It's opposite over adjacent. So once again, we find our angle, C. Okay, opposite and adjacent. So that means hypotenuse is not used in tangent. In fact, that helps a lot in real life. Find a lot of the applications are tangents. So anyway, we have 5 and 12 that make the legs. So in tangent, we only use the legs. So opposite is 5 and adjacent is the leg that runs right into the angle, C. So you would say tangent C is 5 over 12. All right, so find tangent A. So here's our angle, here's adjacent leg, here's opposite leg. So remember TOA, opposite, so we write tan A is opposite, 48 over adjacent, 14. And then simplify, divide out of 2, you get 24 and 7. So tan A is 24 over 7. Okay. And then last but not least, tan Z, remember TOA, tangent is opposite over adjacent. So which angle Z? So here's our angle involved. Opposite is 16, and adjacent, the one that runs right into it, is 30. Not the hypotenuse, because in tangent, we don't find the hypotenuse. So tangent Z is equal to 16 over 30, opposite over adjacent, and we divide out a 2, and we get 8 and 15. Tan Z is 8 over 15. All right. Okay, so the next thing we'll be doing is reciprocal functions. I'm going to stop the video, and this will be the end of part 1. We'll do part 2 in a minute. So goodbye.